Hi everyone, welcome back to SAT 2 Math 2C. We are going to switch gear a little bit. We've been talking a lot about different expressions, radical, rational, we talk about exponents. We're going to get into sort of a little bit of something that's kind of different. So far everything we've been dealing with are what we call equalities, right? So we're going to dive into very simple inequalities. What's the best definition of inequalities? It means what? Things that are not equal, right? But in mathematical terms, just to say something's not equal to something else, not good enough, right? You got to say a couple choices. Whether or not something is greater than, less than, greater than or equal to, or less than or equal to, right? A very, very simple expression. So we're going to kind of like look at two different topics, subtopics. Linear inequalities. What's linear inequalities? Well, we know what a linear equation is, right? Simply, we call it bx plus h, right? Bx plus h. And so an example will be 3x plus 2, right? Let's say if that's equal to 5, we can solve for x, right? I will not insult your intelligence by telling you that this is equal to 1, right? So that's equality. What if I change the gear a little bit and I say, well, this is not quite equal to 5. I'm going to say 3x plus 2 is greater than 5. Then what would the solution be? So if you think about it, then it could be what? It could be a whole bunch of numbers, right? X could be, 5, right? Because 3 times 5 plus 2 is greater than 5. X could be 100, right? X could be 1,000. It could be a lot of numbers. So when we're getting into inequality is we don't get a single number. We get a what? We get a set. A solution, which means everything within that set will satisfy your criteria. So it's a little bit different thinking, right? It's not a singular answer, right? It's a singular set of answers. So everything that qualifies under this condition will work. How do I solve this? If you have a linear inequality, you solve it exactly the same way as you would solve a regular equality, right? So I will subtract 2 from both sides. I will get 3x is greater than 3, and I will divide by 3. I will get x is greater than 1. So this simply says if I have a number line, anything that's greater than 1 will be my solution, right? It's an empty circle because it doesn't include 1. 1 doesn't work, right? Because you plug 1 in there, you get 3 times 1, which is 3, plus 2, which is 5. 5 is not greater than 5, so you cannot include 1. But anything greater than that, it's all game. There's one thing that you got to remember. It's very simple, but everyone sometimes forgets how to do it. When you are multiplying or dividing by a negative number, please make sure you flip the sign, okay? Please make sure you flip the sign. For instance, I'm going to change this a little bit. I'm going to say negative 3x plus 2 is greater than 5. So I'll still subtract 2 from both sides. I will here get negative 3x is greater than 3, right? So if I divide it by, I will have to divide by negative 3. Again, in your head, this should automatically flip. You need to flip this sign. It's no longer greater than, it will be less than. Okay, so always remember you got to flip the sign. So in this case, it will be x is less than negative 1. So if I have to draw that, negative 1, that's my solution set. Okay, everything's the same except when you're multiplying or dividing by negative numbers, please, you got to remember to flip the sign. Okay, doesn't matter if I have a slightly more complicated expression. As long as it's linear, it doesn't matter. If I have 10x plus 2 is greater than 5x minus 10, right? What I can do, well, do the same thing. You can operate exactly the same way, except you got to remember this rule. Minus 5x, right? Put all the terms with all the unknowns on one side, put all the known numbers on the other side, right? So then you'll subtract 2 from both sides. I like to do everything at the same time, which you'll get 5x, this is 0, right, is greater than, that's gone, negative 12. So x greater than negative 12 over 5. Okay? Again, no negative involved, so you have to flip the sign. But if you are dividing by or multiplying by a negative number, please, please remember to flip the sign. You know that the other answer is actually on the SAT, waiting for you to pick. So be very careful. Okay? Think twice before you do inequalities. Nothing tricky, nothing complicated, just something that you got to remember to do. Okay? Don't be careless. Now, so linear inequalities are really, really easy. What about nonlinear? What we're really going to talk about nonlinear is we're going to talk about quadratic. Okay? It's not really nonlinear. We're not going to talk about third power. We're not going to talk about fourth power. We're only going to talk about quadratic, which is, you know, x squared, right? So let's take a look at this. What do we have? X squared plus x minus 6, let's say minus 5 is greater than 1. Okay? How will we solve this? Here are the steps. Okay? Here are the steps. Number 1, make sure one side is equal to 0. Okay? Clear out one side. Make sure one side is equal to 0. How do I do that? Well, that's kind of easy, right? Make sure one side is equal to 0. You can do either side, but obviously, if you subtract 1 from both sides, it becomes a lot easier this way, right? You can do the other way around if you're a little bit masochistic, right? You get x squared plus x minus 6 is greater than 0. Okay? Done. Number 2. Factor and solve for x. Factor and solve for x. All the problems on your SAT will be factorable if they expect you to do this by hand. Okay? Or unless you can choose your calculator. If we can factor, how do I factor this? Plus 3. X minus 2 is greater than 0. Well, solve for x, pretend it's actually what? An equality. So x will be negative 3, x will be 2. Right? And then you need to do sign analysis. Very fancy term for a very simple operation. Okay? What I did here is I got two values. X is equal to negative 3 and x is equal to 2. I basically find two numbers that will make this expression equal to what? Equal to 0. That's not what I'm looking for. I'm looking for what? Make it greater than 0. What I got to do? What I have to do is take these two numbers and put them on a number line. Okay? Negative 3, of course, will be here, and 2 will be here. Right? By virtually putting these zeros there, what we call zeros, right? We divide this number line into 3 sections. All we got to do is test them, see which section makes sense. That's what the essence of sign analysis is. What does that mean? I'm going to look at this, right? I'm going to plug in a number that's less than negative 3. What's a number that's less than negative 3? Let's say negative 10. I don't even have to know the actual number. The beautiful thing about sign analysis, I just need to know the sign. If I plug in negative 10, this is going to be negative. This is going to be negative, right? So the product of two negatives is going to be positive. Slap a positive on it. Done. Pick a number between negative 3 and 2. What would it be? My best number, my favorite number is 0, right? 0 is between negative 3 and 2. If we pick 0 here, 0 plus 3, or, well, that's going to be positive, minus 2 is going to be negative. So the product of 2 will be negative. Pick a number greater than 2, right? You see where I'm going with this? Let's say 100, right? 100 plus 3 is definitely positive. 100 minus 2 is definitely positive. I am going to get a positive. Now, you see the beauty of making this one side is equal to 0, because all I'm saying is what? I want this thing to be bigger than 0, which means I want this thing to be positive. So which two sets of answers work? This set of answers, this set of answers. And they're empty circles because they're greater than 0, not greater or equal to 0. So how do I represent this? This is x is less than negative 3. This is x is greater than 2. That is going to be your solution. Okay? Sign analysis is very, very crucial, because when we get into later terms, when we have more and more complicated equations, when we have more complicated expressions, when we're analyzing rational functions, which will be a big topic, sign analysis will make your life 10 times easier. Okay? So keep in mind, 3 steps. 1, make one side is equal to 0, factor and solve for x, right? And then do the sign analysis and make sure it comes out perfectly. Okay? Now, you can always say, well, worst happen worse, you can plug this in your graphing calculator and get the solution. That's also true. Okay? Now, so this is how we do it. 3 simple steps. Have a whole bunch of questions and practice with these 3 simple steps. Okay? You want to get to the point that when you see a nonlinear equation, an inequality, nonlinear inequality, you will be able to do this automatically.